Okay, so today we're actually talking about graphing radical functions, and we've been working with different kinds of roots. We've been working with the square root, we've been working with the cube root, and the fourth root. Today we're just going to be talking about graphing the square root and the cube root parent functions. We talked a little bit about these last semester, but the parent function for the square root of x equals the square root of x is the most basic function. It just helps you graph it and get you through it. So you can plug points in, and the points that come out are your y's. So remember, it's an input-output kind of function. You could use your calculator. If we look at a table of values, and you truly think about the square root, everything on this side of the square root is negative. So if you were to plug in a negative under here, you're going to get an imaginary number because the square root of a negative is imaginary, and there's no way to plot an imaginary number on the xy plane. So square root functions actually start at the function 0, and if you plug in 0, you get 0 back. And then they work to 1, and they get 1 back. And since it's a square root, that means you need perfect squares. So instead of going straight to 2, because the square root of 2 will give you a decimal, you want to get perfect squares underneath the square root. You want to put inputs in that's going to give you a perfect square. So in this case, we can input 4, get back 2, input 9, get back 3. And then you just plot your points. 4, 2, 1, 2, 3, 4, 1, 2, and 9, 3. So a square root function actually only has a start and an end. It doesn't go on forever. Can you see yellow? Mola. And that would be it. So the endpoint is right here. It's just where your square root function begins. The endpoint in this case is the origin, or 0, 0. The domain is always going to be x is greater than or equal to, because we can never go into the negative numbers. Or we will never go out to negative infinity. And your range is going to be y, and depending on if you have a increasing function like this, or if it decreases down, it's going to be greater than or equal to, or less than or equal to. In this case, the domain is always greater than or equal to the x value of your endpoint, and the range is going to have the y value of the endpoint. Now let's take a look at the cube root parent function. The cube root parent function is like the square root parent function, except it works with perfect cubes. And remember, you can, unlike the square roots and the fourth roots, you can actually take the cube root of a negative number. It just gives you back a negative number. So unlike where this starts and ends, this one, the cube root parent function is going to be able to go into both sides. So it's the cube root of x. Remember, it's also the most basic. So if you were to plug this into your calculator and go look at the table, you could go into the negatives and you could go into positives. And since we're wanting perfect cubes, you're wanting to put in an input an x value that's going to give you back a, you want to input x values that's going to give you a perfect cube underneath your cube root. So one thing could be, we could do 0, 0 in the middle. 1 would give you back 1. But likewise, -1 gives you back -1. And if you input -8, you get back a -2, and inputting 8 gives you back 2. So cube roots, negatives and positives. A negative gives you back a negative, a positive gives you back a positive. Remember, the cube roots jump from 1, 8, and then they go all the way up to 27. So in our graph only goes out to 10. You would then plot your points. 0, 0, 1, 1, 8, 2. And remember that a cube root function, or a cubed function, looks like this. So the cube root function is actually just taking the cube root. The cube root function takes the cube function and turns it sideways. So when you connect your dots, it's just a sideways cube root. The turning point. Square root functions have an endpoint at the end of the graph. Cube root functions have a turning point, and it's where the graph goes right here, where it starts turning the direction and just a little right there. It's in the middle right here. In this case, this one is also the origin. And the domain and range for a cube root function is just like the cube function. It's all real numbers. You can write out all real numbers, or you can just write it out with the r with the double back. It's going to go forever into negative infinity and positive infinity, both in the x and y direction. All right, let's talk a little bit about transformations. We've already talked about transformations about 3 times already on 3 different lessons, so let's review. Remember, the transformations of square and cube root functions is going to be f of x equals a to the nth root of x minus h plus k. N will either be 2 or 3 since we're going to be working with square and cube. H is in charge of your horizontal shift. So H, remember, moves you left or right. If H is positive inside of your function, then that means you're moving left. And if H is negative, it means you're moving right. K is in charge of the vertical shift. K moves you up or down. K is outside of the cube, out of the root. It's not underneath the radical, it's on the right side of it. And if your K value is positive, you're going to shift up. If your K value is negative, you're going to shift down. A is in charge, endpoint and turning point. So H and K always play a big part in everything. And in this case, your endpoint and your turning point can be found at the coordinate point H, K. So remember, A is in charge, and then A is in charge of any dilations or reflections across the x-axis. So if A is negative, the function is reflected across the x-axis. So in this case, it would just take it, and instead of being in quadrant 1, we're going to go into quadrant 4. And instead of being in quadrant 1 and 3, you're going to be in 2 and 4. So if A is greater than 1 and if A is less than 1, or between 0 and 1, remember these are dilations. So you're either going to have a vertical stretch or a vertical compression. If A is greater than 1, you're actually going to have a vertical stretch. So your function is going to go stretch out vertical wise. But if your A is a value between 0 and 1, it's a compression. And a compression is going to shrink you down. So let's compare all of these. We're going to describe these next 4 transformations of each function and compare it to what happens to the parent function. So looking at the first one, f of x equals the square root of x minus 7 plus 2. If needed, state your h and k. So in this case, since our original equation has a negative already in it, h is a positive 7 and k is a positive 2. So then you would say, okay, h horizontal. Since it was negative in the function, we're going to go right. So you just tell me the direction it's going by how much. And then k is vertical. Since it was positive, it goes up. So this function was moved right 7 and up 2 compared to the original one. Okay, if we look out here, remember if there's a number in front of your radical, that is your a value. If there is no number underneath the radical where h is supposed to be, it is 0. And in this case, k is negative 1. If h is 0, that means that your graph was not moved horizontally left or right. It's still there at the origin. So if a is 4, that's greater than 1. So there's a vertical stretch by 4. Since k is negative 1, that's a minus. So, and then it moved down 1. So negative just tells you 1 in the down direction. And that would be that. All right, let's look at number 3. F of x equals the negative cube root of x plus 3. Remember, if it helps you, state what they are. If not, you can just look up here. There's a negative. A is negative, so there's going to be a reflection across the x-axis. Okay. H. Remember to take the opposite side. It's a negative 3. Since it was plus in the function, that means you moved left. And the reason you moved left is because H is actually negative. And when there's nothing out here, K is 0, so there was no, it didn't move up or down. It just stayed there. And then this last one. Notice that 1/2 is between 0 and 1. So there's going to be a vertical compression. And the amount that it moves is just the values of A, H, and K. So A was 1/2, so there's a vertical compression by 1/2. H is 2, minus moves means we move right. So you're moving right by 2. K is negative 6, minus means we move down. So you're moving down, and then by the value, 6. And that would be that for that. You're just describing what happened to this function. Like, what did you do to these functions to make them differ from the parent function? Now, these graphing ones, I'm not going to do all of them. I'm only going to do a couple of them per page. And then remember the key will be posted the next day. All right, so these next two are giving you the transformations and it's wanting you to write the function. So the square root parent function is reflected across the x-axis, then shifted 7 units down, 7 units left, and 1 unit down. Write an equation that represents the function. So first off, it's a square root. So that means n is 2. And when you plug it in, you're going to have an index of 2. All right, so it's wanting you to write an equation. This is going to be your equation. So best bet is identify A, H, and K, and then plug them in. So take it one at a time. So it says that it was reflected across the x-axis. Reflections are negative, and if there was no vertical stretch or vertical compression, it's just 1. Okay, that's 1 down. Shifted 7 units left. That means you went left 7. Okay, 1 unit down, minus 1. So taking these and plugging them in, you get f of x equals negative 1 square roots of x minus negative 7 minus 1. And remember, a double negative is a plus. And that would be it. So for number 6, a cube root function has a turning point located at negative 2, 3. Write an equation that could represent this function. First, note that you're working with a cube root. So that means n is 3, and your function is going to have that 3 right there on its little pedestal. But the only thing that's differing between these two is the index. Also, instead of telling us the transformations, it just told us the location of the turning point. But remember that all endpoints and the turning point are at h comma k. So it's telling you that the it's not talking anything about the dilations or reflections. So that means A is just going to be 1. It's telling you that H is right here, is negative 2, and K is 3. So when you plug it into the function, you're going to have f of x equals A is just 1, cube root of x minus H plus K. Whoops, we want the value of K, the value, which is 3. double negative again turns into a plus. And that would be it. All right. Let's look at some graphing. So these directions tell you to graph each radical, identify the key characteristics. So we're going to start with this one right here. The key characteristics. We will be doing domain and range, endpoint/turning point. We're not going to be doing end behavior, and we're going to do increasing and decreasing intervals. So let's start by identifying h and k. In this case, there's no other number underneath the square root, so h is 0, k is 5. Since this is a square root, square roots have endpoints. And remember that the location of the endpoint is at h comma k, so our endpoint is going to be at 0 comma 5. So now let's start plotting some points. We're going to start with 0, 5. And you could do this two ways. You could plug in different values of x and then figure them out by hand, or you could use your calculator, put them in y equals, and go look at the table. In this case, when you're working with the square root, you're starting at the endpoint and slowly working your way up. So remember that perfect squares go from 1 to 1, 4, 9, 16. 16 is too big to be on this graph. Like we can't have an input value of 16, but we can have an input value of 1. If we put 1 in this equation, square root of 1 is 1, plus 5 is 6. Okay, so that means the next one's at 1, 6. Okay, next perfect square would not be 2 or 3, but 4. If you put 4 in for x, square root of 4 is 2, plus 5 is 7. Uh, 5, 6, 7, 8 are not perfects, but 9. If you plug in 9, you get square root of 9, which is 3 plus 8. 3 plus 5, which is 8. So it'll be 9, 8. And you should get a little bit of a curve. And then you would just connect the points. All right, so domain is x values. Notice that all your x values start at 0 and go towards the right. So your domain is all x values greater than or equal to 0. Your range are y values, and notice that the smallest y value, if you come down, go up, is right here, the endpoint, which is 5. And then it continues to go up to infinity. So your range would be y is greater than or equal to 5. So your domain is always going to be x is greater than or equal to, and then your h. Your range, if a is positive, then it is y is greater than or equal to k. If a is negative, then it's going to be y is less than or equal to k. You're either going to have an increasing or a decreasing interval. You're going to have an increasing interval so long as you have a positive. So if a is positive, you'll have an increasing interval, and you will start at h and go to infinity. And you could put none or just put a line through the other interval that you do not have. And that's going to be it. All right, so let's look at number 9. We have 3 square roots of x plus 1. H, take the opposite sign, negative 1. K is 0. So our turning point, our end point, because we're in square roots, is going to be negative 1, 0. So you can start by going ahead and plotting that one. If you want to make a table, go ahead. If not, you could just look at your calculator. You're going to want to plug in. So the next x to plug in is going to have to add to this one to give you a perfect. If you plug in 0, 0 plus 1 is 1, square root of 1 is 1, times 3 is 3. So your next one is at 0, 3. All right, the next perfect square after 1 would be 4. The only way to get 4 is if you plug in a 3, because 3 plus 1 is 4. Square root of 4 is 2 times 3 is 6. And then the last perfect square after 4 is 9. The only way to get 9 is if you plug in an 8. Square root of 9 is 3 times 3 is 9. We plugged in 8 and got 9. And then you just connect your dots. All right, your domain, remember it is x is greater than or equal to. Your range is going to start with y. Because our a is positive and we are in the first quadrant going up, we're going up in a happy direction, your y is also greater than or equal to. Your domain would be the h value, which is -1, and range is y value, which is, or k value, which is 0. We will not be doing end behavior. And just like the first one, this isn't increasing. It goes here. If you put your pencil and you keep going up, it is increasing. If you put your pencil on the endpoint and you follow the graph and you go down, that is decreasing. We do not have a decreasing. We increase starting at the h value and go off to infinity. Remember, brackets means that you start at -1 and touch -1 since it's a closed dot. Let's look at number 10 and then move on to the cube roots. All right. So number 10, start with the same thing. Identify h and k. Remember to take the opposite. If it says -2, then your h is a +2. K is right here. So your endpoint is at 2, 3. So when you're making your chart, you're going to start it at 2, 3. All right, so remember that you're wanting to plug in numbers that's going to give you a perfect square down here. Or if you would like to, you can also go into y equals, plug in the function exactly as it looks. -square root of x minus 2 plus 3. Go look at the graph and see all these errors. That's because you can't have them. So notice how the table also starts at 2, 3, and go look for the whole numbers. We have 3, 2, 6, 1, 11, 0, and that's as far as you can go since our graph only goes to 10. 11, 0 is going to be right about here. 6, 1, 10, 9, 8, 7, 6, up 1, over 3, 1, 2, 3, 1, 2. So notice that this groove is actually, if you put when you put your pen on it, your pencil, and you follow your dots, how they go down, it curves down. When it curves down, you're going to have a decreasing interval. So range, x is greater than or equal to y. Domain, x is greater than or equal to. Your range is going to start with y. But notice how we go down. When we have a decreasing interval, our range is less than or equal to. X is greater than or equal to k. H, y is less than or equal to k. And then your decreasing interval is going to always start with a bracket. Either of your intervals are always going to start with a bracket and go to infinity. They start with the x value of 2 to infinity. All right, let's look at these cube roots. Starting with number 11. You're going to start at the same. You're going to look for h, which is -3, take the opposite sign. Look for k, which is a +2. And in this case, instead of endpoint, we have a turning point. So just a reminder that cube roots look like this. They're sideways cubes. So your turning point is negative 3, 2. 1, 2, 3, 1, 2. The domain and range of the cube roots is always going to be all real numbers. Okay. Let's see. If you would like to, you could also make a chart here. Except instead of putting the turning point at the beginning, you're going to put it in the middle, because the turning point is right here and it's going to have points to the right and left of it. To use the cube root, you hit math and go down to number 4. And then you're going to plug it in as it looks and go to the table. I notice that this time it actually goes to both sides, but you want to go look for that turning point. Go look for negative 3, 2, wrong direction. And you're going to graph points around it. So negative 2, 3. Mm, 5, 4. Oh, nothing over 10, and that's as far as we go. So if you only found 2 dots to the right, you may only find 2 dots to the left. Negative 4, 1. Negative 11, 0. You do not have to do the table. Negative 2, up 3. Over 5, 1, 2, 3, 4, 5, up 4, 1, 2, 3. Negative 4, 1. And the other one, negative 11, negative 1, negative 11, 0 would be right there. So when you graph this one, I like to start at the turning point and curve up and then curve down. All right. To decide if this is an increasing or decreasing interval, start with the leftmost and follow the graph. In this case, you go up and you keep going up. So that is increasing. So we won't have a decreasing. And because it goes to the left negative infinity and to the right to positive infinity, cube root actually goes from negative infinity to infinity. And then I'm going to do 12, and then that'll be it. So H, notice, is not there, and K is not there. So they're both 0. That is your turning point. Okay. 0, 0. All right, let's see. The domain and range is all real numbers since we're working with a cubic. And let's plug in some numbers. Negative 2 cube roots of x. Go look at the graph. Go find the turning point and graph around it. So negative 1, 2. And you're going to want your x values to go up to negative 10, to go between negative 10 and 10. Let's see, 1, negative 2. And then 8, negative 4. And then you just want to plot those. Negative 1, 2, 1, negative 2, 8, negative 4. You could come in from the left. Ooh. And then connect the dots. And notice if you do that, you're going down. When you follow the graph, you're down. So that is a decreasing interval. Negative infinity to infinity. This graph is going to go to all real numbers, infinity, all everywhere, up and down, x and y. All right, and I will be back tomorrow to help you guys on the homework. If you have any questions at all, you can go right next door and ask Miss